Like I'm pretty sure no one knows what an anti-attractor is, right? And in case you're new here, like if this is your first time listening to the live stream, let's get back into it. Or if this is your second time listening to it, let's get back into it again because I mean, we're here to learn together. So I looked it up again. I mean, I know what it is now. I'm educated. All right, I'm just playing. So let's look up what an anti-attractor is, right? Because we're educational here, right? So let's use AI. So I said, here's my prompt. I said, what is an anti-attractor in terms of AI? All right. So this is oh, totally cubic vibes here. Ooh, sorry, I just woke up, so gotta get loosey goosey. All right. In the context of advanced AI theory, handed to CFB, an anti-attractor or anti-fractal attractor is a conceptual framework describing a system designed to intentionally avoid settling into stable, repetitive, or predictable patterns. Mm-hmm. Mm-hmm. Right? While traditional AI models, right, like LLMs function as attractors, the opposite of an anti-attractor, right? Obvi. That pull responses toward the average or most probable outcome based on training data. An anti-attractor system forces the AI to constantly generate new orthogonal dimensions of thought or information. Hmm. Or you can say orthogonal. And then guess what? You have the goal to use another word that we have to look up. All right, so check it out. Orthogonal. Orthogonal generally means intersecting or lying at right angles, serving as a generalization or perpendicular in geometry, linear algebra, and mathematics. Bum, 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 bum. Or, but this is what we're looking for right here. A definition that works well is a way of thinking that involves exploring seemingly unrelated ideas to generate new insights. From from a practical standpoint, orthogonal thinking allows us to tackle problems from unrelated angles. This is especially helpful in fields where innovation is critical. So it takes that perpendicular type of concept of thinking, like you think at completely opposite angles. So check this out. So, so go back to here. So anti-fractal structure. Instead of folding back onto itself, self-similarity, like a classical fractal attractor, the anti-attractor acts as a spectral whitener, destroying patterns and avoiding resonance to create maximum unpredictability and novelty. Yo, imagine computing at a bazillion iterations per second in the most efficient way possible at every iteration. Yo, we stumbled onto some insane goodness. And then if you apply the Neuraxon model to that, I can't wait until the Neuraxon is latched onto Agarth. I wonder what'll manifest. All right. Open phase space. Traditional AI operates in a closed fixed dimensional embedding space. Uh-huh. An anti-attractor system operates in an expanding phase space where new dimensions are added orthogonally. Ding, ding, ding. So essentially perpendicularly to existing ones, allowing the AI to create new prime thoughts rather than interpolating within old new ones. Ooh wee. Ont- ontological pain trigger. An anti-attractor system thrives on ontological pain, the gap between an AI's internal model and a new irreconcilable reality. Instead of ignoring this gap or hallucinating, the system uses it to trigger the new creation or the system uses it to trigger the creation of a new conceptual dimension. Ooh, ooh, ooh. This all sounds so familiar how the brain works. All right, search optimization. Anti-attractors are seen as optimal search algorithms for infinite space, similar to how prime numbers emerge as symmetrically irreducible residues in a sieve. Whoa. Maximize novelty, avoid repetition, generation of new orthogonal dimensions. Yo. And soon, didn't he say they're gonna start like doing visualizations of stuff? All right, AGI, contextual applications. True sentient True sentience is argued to be governed by an anti-attractor law, where a necessary absence perpetually drives the system to escape stasis rather than finding a fixed point of truth. Sovereign AI. To create AI that is autonomous rather than just a smart search engine, developers might use anti-attractor architectures that allow the model to change its own internal structure. This concept is discussed in context of Ars Rerum, a framework that focuses on generative, open-ended systems rather than simple statistical pattern matching. Good God Almighty! So that's quite interesting. You know what I wanted to look at real quick? I think I have at least 10 more minutes. Where's the Qubic page? I want to look at the Neuraxon thing. Because they just added like a new sense or something like hearing or some shit. Aha. Here it is. Here it is. Are we still going? All right, cool. We share this tab. Neuraxon agents. Check this out. Neuraxon agents started clustering together. If you're new here, Neuraxon is this model that these actual like scientists came up with that are working with the Qubic team. It's like this, and they've got scientific papers already accepted into like major publications, and they're about to go present them like at these big conferences. Like it's a pretty big deal. So anyway, Neuraxon is the model that they came up with. So check it out. Neuraxon agents started clustering together. Nobody probe. Wake up. What? Unique New York. Unique New York. Unique New York. Nobody programmed them to do it. There is no rule in the code, no reward for staying close, no instruction of any kind. It just happened. Last week's Neuraxon build added hearing as the fourth active sensory channel, joining vision, proprioception, and touch. What you gotta? What the heck is proprioception? I'm liking this proprioception. It's the body's sixth sense, unconscious ability to sense its position. Oh, interesting. So check it out.
Proprioception.
Proprioception, the unconscious ability to sense its position, movement, and orientation in space without visual input. Ooh la la. Nice. If you ever trained with your eyes closed, you know the deal. You ever just stand there with your eyes closed, you'll lose your balance. All right. Each agent now listens to its environment, produces its own signature sound, and inherit audio traits from parents and peers. Ooh, what the heck? Dude, these guys, how do you code that? All right, within the simulation, agents with similar sound signatures begin finding each other. Emergent behavior unprompted, undirected. This is the same pattern the team observed when agents evolved visual recognition of food sources and developed spatial navigation without being told to. Ooh la la. The research principle is this: give an agent a sense, Give it heredity, give it evolutionary pressure. The behaviors that follow are not written, they are discovered. You can watch it live. Click any agent in the build and pull up its bio-brain chem panels, real-time tones, musicality scores, songs learned over its lifetime. This is accessible. This is the accessible light build. The research architecture underneath it is the basis for two papers currently in peer review, one submitted to A Life 2026 in Waterloo, on to AGI 20, and one, excuse me, and one to AGI 2026 in San Francisco. Ooh la la. Ooh la la la. So you can check it out yourself at GitHub. Make sure you go give it some stars. I already gave mine some stars. I'm signed out because I don't want to like dox my account, but sign in. You can sign in with your Google account. Just give it some stars, man. It has 541. We can easily get to 1,000. We can get to 1,000. Just click over here, sign in with your Google, give it a like. Easy peasy. Or sign in with your Apple account, whatever. It's like a one-click sign up. Or sign in with your Yahoo. And give it a like. It's free. Takes easy effort. Easy peasy. Easy peasy. All right, let's check out Doge mining profitability real quick. Let's check it out. Let's check it out, man.